we're talking about combining like terms. So, on your previous lesson, you identified like terms and you learned a vocabulary. So, for this lesson, we are going to be learning how to combine like terms, aka, we're simplifying expressions. Now, just to review with you, what are like terms? Like terms are things that look alike. They share the same variable with the same exponent. So, if you look right here on this example, 7x and 2x are like terms because they both have a single x. And in fact, this actually has an invisible exponent of 1. But don't let that throw you off too much. Notice the variable and the exponent match: x1, x1, x1. Our next example is 3x squared and negative 2x squared because they both have an x and they're both raised to the second power. That's what makes them like terms. Now, negative 5 and 9 are like terms because they are both constants. Just an example of unlike terms would be something like 3x squared and 4x. These would not be like terms because the 3x to the second has a power of 2 and the 4x to the first has a power of 1. That makes them not like terms. Now we're going to talk about like terms in a more kind of applicable way. I like to discuss it using your favorite foods and whether or not you like to put them together. So one of my favorite foods is pizza. So I got my pizza slice right here. And my other favorite food is chocolate. Now, I don't know about y'all, but I would never want to mix my chocolate and my pizza ever. It sounds very strange. So we're going to use this to identify our like terms and whether or not they go together. So we'll start from the left. We'll say, okay, 3x, I'm going to make that a slice of pizza. Well, plus 12, we know that 12 is not a like term with 3x, so that must be my chocolate. So I've got pizza, I've got chocolate. Now I've got my 7x, which is again pizza, because it matches the 3x. They are like terms. And the plus 5 again is a constant, so it's chocolate. Now, like I said before, I don't know about y'all, but I would only want my pizzas with my pizzas and my chocolates with my chocolates. So just like before, when you identified the like terms and you put them in the T chart, we're going to be doing the same thing. So we're going to make our T chart right here. And we're going to try that again. So then we're going to have pizza in one side and chocolate on the other. So just like last class, you're going to take your terms and you're going to move them into their corresponding pile. Pizza with pizza, chocolate with chocolate, because nobody wants pizza with chocolate. That just sounds nasty. I don't know about y'all, but that just sounds nasty. So I got pizza with pizza, chocolate with chocolate, because pizza on pizza works. Chocolate with pizza is no bueno. Nobody likes chocolate with pizza. I have never met anybody that likes chocolate with pizza. So now we just need to talk about our totals. So if we were to total this up, what would we get? What would we get here when we total this up? Well, 3x is representing pizzas. So that means that I have 3 pizza slices. And then I have 7 more pizza slices because it's plus 7. Another way you could look at this is 3 plus 7 gives you 10. So you now have 10 slices of pizzas, or 10x. And then you have 12 pieces of chocolate plus 5 more pieces of chocolate, means you have 17 pieces of chocolate total. Now, this isn't your final answer. This is just an organizer. Our final answer we'd have to write as an expression. So we start with 10x. But then that 17 is problematic. It's a positive 17. And since it's positive, that's what's going to make me add. So add 17. And this is like the general thing you can think about when you're combining like terms. Would you or would you not want your pizza with your chocolate? So same x's, same variables go together, and constants go together. So basically like terms go with like terms. Now I'm going to break it down step for step for you. Here, I'm asking you to simplify this expression: 12r plus 5 plus 3r minus 5. Your first step is going to be identifying your like terms or using that T-chart that you guys used last class. So we'll make our T-chart here. And actually, I'm going to make it in something else so that it stays on the screen. So we're going to make our T-chart. And now we're going to do just like you did on the homework and the boom cards. We're going to drag our like terms to where they belong. Before I do that, I need to identify that I have an r, no other r, well, no other like r squareds, and I have constants. So my category is going to be r, and my other category is going to be constants. So now I'm going to drag my r's to their proper place. So 12r plus 3r, and my constants belong with my constants. Now comes the combining like terms side. Step 2, add down. Now what that means is you're going to put a totaling line, and you're going to be adding the number on top to the number below and all the numbers in the column. So you have 12 plus a positive 3 gives you a positive 15r. Now you have positive 5 plus negative 5. They actually cancel each other out to be 0. And now step number 3, rewrite our answer. If this were any other number, we would write it. So we have 15r plus 0. But do I really have to write a plus 0? No, I don't. So it's just 15r is our final simplified answer. Next, we are going to do another example where we have simplify n plus 4 minus 9 minus 5n. Step 1, set up our cheat chart. Whoops. And it's not going to go, of course. All right. Step 2, identify what we have here. We have get n's, and we've got constants. If it's hard for you to identify that, just start with your first one and say, okay, I've got n's. Let me drag all my n's down. What do I have left? Constants. So that must be my other column. Constants. And then drag all my constants down. Step 1 is accomplished. Now we move on to step 2. Add down. Totaling line. Addition. What's the invisible coefficient on this n? Well, the invisible coefficient is always 1. So this is saying 1n plus negative 5n. Again, it's like integers. Who's going to win? The negatives. By how many? 4. So our answer would be negative 4n. Just going to extend my line a little bit. Then I have negative 4 plus negative 9. Again, who's going to win? Team negative. By how many? 5. Step 2, complete. Step 3, we're going to rewrite our answers. So we have negative 4n. And then here, since this is a negative 5, we can say it's minus 5. Because negatives and minuses can be interchangeable when you're talking about operations and signs when you're writing your expressions. If you wanted to write negative 4n plus negative 5, you could have done that as well. Both of these are acceptable answers. This is the one we like to see in math more often. Negative 4n minus 5. Okay, so what we're going to do now is we're going to pop out to your foldable and we're going to do some work. So take your foldable out. We're going to be doing just one column today. Alrighty, guys, you should have your foldable out that we've been working on for a little while. Open it up, and today we're going to work on just part of the lower half. All right, so today we're going to focus on integers right here. On Monday evening, you'll focus on decimals, fractions, mixed numbers, all that jazz. Okay, so we're still going to follow the 3 steps. Just to remind you, step 1 is to make your T-chart. Step 2 is to add down. And step 3 is to rewrite. So if we start out with step 1, let's make our T-chart. Now, I like to use colors when I do combining like terms, and I always start with my first term. I say, okay, I've got 8x. So you can circle it, you can highlight it in a certain color. That means that the first item I'm talking about are x's. So I'll go ahead and I'll do 8x. Now you can do this a couple of different ways. You can then search for all your x's, or you can move on. I like to search for all my x's, so I'm focusing on one thing at a time. Then I say, okay, negative 9 doesn't have an x, not a like term. Positive 2x. Oh, that's got an x, so it's a like term. I'm going to put a box around it, and notice again, I'm taking the sign in front. It tells me whether or not that 2 is positive or negative. So positive 2x. No other x's, so I'm done with my x column. New color. This is a constant right here, negative 9. So I know I'm dealing with constants, which I use a C to represent. I've got negative 9, and I see that I only have left is a positive 4, which is my other constant. Now, my final step is 2, I need to add down. So I have 8 plus a positive 2x. Same team, and we're getting bigger, so we have 10x. And then we have, for our constants, we've got negative 9 plus positive 4. Who's going to win? Team negative. By how much? 5. Now I have step 3, rewrite my final answer. I take my first answer from my first column, which is 10x. Take my second answer from my second column. Negative 5 becomes minus 5. This is my final simplified answer. Now, if you're feeling confident, I'd like for you to challenge yourself and pause the video and attempt the next 2. If you're not feeling so confident, follow along with me for the next 2. And then if you're getting confident along the way, pause it for the last one. I want you guys to try and do this, but if you can't get practice, you will always have the boom cards for backup. All right, step 1, T-chart. Step 2, start with your first term, which is 11a. That must mean I'm talking about A's. I've got an 11a. Any other A's? No, that's a B. That's a constant. Oh, I got negative 5a or minus 5a. And a B. So my A's are done. I look at my next term. Oh, I got a B. That must mean I'm talking about B's. I've got a positive B. That's a constant, so no. And I got a positive 2b. Wait a second. I've got something left over here. I've got a constant. So this is the first time you've seen 3 columns in your T-chart. But it works exactly the same. So here you have a positive 8, which is a constant, a positive 8. Now we are up to step 2, which is add down. So we have 11a plus negative 5. Team positive is going to win, and they're going to win by 6. So we have 6a. Positive, careful here, there's an invisible 1 here. So you have 1b plus 2b. Gives us a grand total of 3 b's. Then we have 8 plus nothing, so that gives me a positive 8. Step number 3, we're going to go ahead and write our answer, which is 6a plus, because it's a positive 3b plus 8. And this is the most simplified form of that expression. You can end up having even 4 columns in your T-chart. It just depends upon how many different types of terms you have. And that's okay. So whenever you forget about this 1 here, just think about yourself, okay, if I've got a B and then I've got 2B, well, that represents literally 2 B's. That's like saying B plus BB. Well, that's 1B, 2B, 3B. So you have 3 B's total. 3B. Just a little word of advice. All right, let's go on to number 3. Make your T-chart. I always start out with just 2, and then I go from there. First term we have is a negative 10k to the second. So that must mean that we're dealing with k to the second powers first. So far, I have a negative 10k to the second. 7k? Nope, not a like term. Negative 3k squared, yes. Like terms. Positive 4? No, not like terms. Negative k squared? Yes, like terms. And plus 5k, not like terms. Done with the k's. On to my next term, which is positive 7k. So we have k. We just dealt with our k to the seconds. Now we're dealing with our k or k to the first. Remember, there's an invisible exponent of 1 there. So I've got 7k. 4 is a constant, so no go. And then plus 5k. All right, I still got something left over, so I got to add a third section to my t-chart. 4 constants. Constants here, which I've got a positive 4. Now we're up to step 2, where we add down. Negative 10 plus negative 3 plus negative, what's invisible here? 1. So negative 10 plus negative 3 gives me a negative 13. Negative 13 plus negative 1 gives me a grand total of negative 14k to the second. Now it's important here to realize that your k to the seconds don't become like k to the sixth, because it's like 2 plus 2 plus 2. It doesn't become like k to the eighth, 2 times 2 times 2. It simply stays the same. So we have k to the second power throughout, because it's just making your like terms come together to make one big term out of all their little pieces. Now I have negative 7k plus 5k gives me a positive 12k. And I didn't extend my t-chart down low enough, so I'll lower that. Sorry for the bell in the background, but we'll finish up. We only have one constant, so 4 plus nothing is a positive 4. And our final answer here is negative 14k squared plus 12k plus 4. Sorry about the announcements there. And now you guys are going to go ahead and try them on your boom cards. Good luck. I hope this helped. And let us know if you have any questions.